It's kind of strange when you really sit with it, that everything around you feels solid, predictable, and real. Because underneath all of that, it's just tiny things following rules. Not objects, not stuff the way it feels. Just particles interacting. And somehow, all of that turned into you and me, your house, your pet, even your phone. Which already feels like the universe got a little carried away. So let's go back. Not exactly to the beginning, because we don't fully know what that even means, but to the earliest point we can actually describe. Before stars, before planets, before anything recognizable, there was a state of extreme energy. Not matter, not objects, just energy. Compressed, dense, everywhere. Now here's the problem. Energy sounds like an explanation, but it really isn't. So what even is energy? Energy is basically the ability for something to happen, for things to move, to change, to interact. If nothing can change, there's no energy. If everything is constantly changing, then energy is everywhere. So in the early universe, it wasn't full of things, it was full of change itself. And then it expanded. Not into space, but as space. Space itself stretched, distances grew, and energy spread out. And when energy spreads out, things begin to calm down. That's what we mean when we say the universe cooled. Not cold, just less chaotic. As everything slowed down, patterns became possible. Particles formed, protons and electrons, basic pieces with properties. And this is where rules come in. Electrons carry negative charge, while protons carry positive charge. Opposites attract, and like charges repel. This isn't a decision or a preference, it's just how the system behaves, the rules it follows. So naturally, these particles begin to combine. Electrons gather around protons, forming atoms, the first stable building blocks of everything. And stable doesn't mean permanent, it just means they last long enough to build something else. Now, when atoms interact, they don't just sit there, they rearrange. Electrons shift positions, bonds break, and new ones form. And here's the key part. When these changes happen, energy moves. Sometimes energy is absorbed, and sometimes it's released. When energy is released in a certain way, you see light. When it spreads through matter, you feel heat. So what is heat, really? It's just motion. Tiny particles moving and colliding faster. And light? It's energy traveling as waves, moving through space at a constant speed. Fire is just a fast, visible version of all this. Atoms rearranging rapidly and releasing energy faster than it can spread out quietly. So yeah, fire looks dramatic, but it's really just atoms being very active. Now here's where things start building up. Nothing in the universe is perfectly still. Everything is already moving. And then there's gravity. So what is gravity? Gravity is the tendency for things with mass to pull toward each other. Not because they want to, but because mass changes the shape of space itself. You can think of it like this. If space were a stretched surface, mass would create dents in it, and other things would move toward those dents. Now combine that with motion. Things are already moving, but they're also being pulled together. So you get a balance. Motion tries to spread things out, while gravity pulls things inward. And that tension is what creates structure. Regions with slightly more matter pull in more. More mass means more gravity, which pulls in even more matter. And over time, those regions become dense enough and hot enough to ignite. Stars. Inside stars, something extreme happens. The pressure is enormous, and the temperature is incredibly high, so high that atoms are forced together. This process is called fusion. But what does that actually mean? Normally, atoms don't want to combine because their positively charged centers repel each other. But inside a star, the pressure is so intense that they're pushed close enough to stick. When they fuse, they form a new, heavier atom. And here's the important part. A tiny bit of mass is lost in the process and converted into energy. That's where a star's light and heat come from. Fusion is basically matter turning into energy. And over time, this process creates heavier elements like carbon, oxygen, and iron, the same elements that make up your body. So every breath you take, every thought you have, comes from something that was built inside a star. Which sounds poetic, but is also just physics doing its thing. Not everything collapses into a star, because everything is still moving. So instead of falling straight inward, matter begins to spread out into spinning disks. These are called accretion disks. Imagine particles moving toward a center while also moving sideways. They don't fall straight in, they spiral. And that motion naturally flattens everything into a disk shape. Inside these disks, particles collide. Sometimes they stick together. Sometimes they break apart. But over time, more and more material clumps together. Small pieces become larger ones, rocks, then planets, then moons. And they stay in orbit not because they're floating, but because they're constantly falling and missing. They're moving sideways fast enough to keep missing the thing they're falling toward, which is honestly one of the coolest loopholes in physics. And out of all those systems, one planet ended up with a very specific combination: liquid water, a stable temperature, a steady source of energy from a nearby star. The Earth. Not special because it was designed that way, but because out of countless possibilities, this is one that worked, like one branch on an unimaginably large tree. And on that branch, something happened that changed everything. Matter didn't just exist anymore. It started to organize, to adapt, to replicate, to live. And that's where things get even stranger. This is Mind in Lines, making sense of people. Kind of.